Okay, in this one, we're given the altitude perpendicular to the hypotenuse of a right triangle is 12 centimeters. All right, so let's draw that in. Here's a right triangle. And we have the altitude perpendicular to the hypotenuse. So that would be this segment right here. It's perpendicular, so we pick up some right angles there. And let's call that, well, we're given its length, so let's write 12 there beside it. Okay. Then it says express the length of the hypotenuse. Okay, so let's go ahead and label that. Let's call it h maybe. And make sure we indicate that it goes the full length of that segment. We want to express the length of that hypotenuse as a function of the perimeter. Well, let's see, it's hard to label perimeter here on the picture, but we know the perimeter is the sum of the lengths of the three sides. So let's call this one x, and let's call this one y, and maybe over here we write something like p equals x plus y plus that third side of h. Okay. All right, so now where do we go? Well, what do we know? It's a right triangle, so we know Pythagorean Theorem holds, which tells us x squared plus y squared had better give us the length of the hypotenuse squared. Right? This guy squared plus this guy squared is this guy squared. What else do we know? Well, what about area? We know that if I multiply the height of this triangle, which is y, by its length and divide by 2, that's its area. So xy over 2. How does that help, though? Because we really want to ultimately get a relationship between p and h. And right now I have two equations involving p and h and x and y. So I need some more equations, some more relationships to put together with this so that I can eliminate that x and y. Well, the advantage to looking at the area is that you can find the area of this particular triangle two ways. You can treat this as the base and this is the height, in which case this is the area of the triangle. Or you could imagine rotating this thing around so that this is the base and then the height would be the length of the altitude. So you could also calculate the area as height times base over 2. And of course this simplifies to just xy is 12h. Okay, so that's useful. We've got another relationship between x's and y's and h's like we do here. Okay. Now what? Well, this is a tricky problem, I will admit. But look at the different pieces we have here. We've got an x squared plus y squared. We've got an xy. Those things should kind of click together in your brain. You should remember that x plus y quantity squared, isn't that x squared plus a y squared plus a middle term of 2xy? These things are very closely related, right? This is x squared plus 2xy plus y squared. Or using this and this, couldn't I say that's the same thing as, let's see, x squared plus y squared is an h squared, and 2xy would have to be twice that. So plus 24h. Well, that's good. That equals x plus y quantity squared, but I really need a relationship between the hypotenuse length and the perimeter. I've got to get the perimeter in here. I've got hypotenuse length. Could I write this in terms of perimeter? Or maybe at least perimeter and hypotenuse? Well, the only equation I've got to work with is this one up here. Can we solve it for x plus y? Wouldn't this say x plus y is p minus h? So now I can take this and plug it in for x plus h. So this becomes p minus h quantity squared. Okay? That's a tricky step. both in coming up with this x plus y squared and making this replacement. Not terribly intuitive. That requires a little creativity. But once we get to here, we're home free. We have an equation, hence a relationship, in terms of only the perimeter and the hypotenuse. If we want to express the hypotenuse as a function of the perimeter, that means we need to solve for the hypotenuse. Okay, so let's proceed. Let's expand this out. This is p squared minus 2ph plus h squared equals h squared plus 24h. This is wonderful because the h squareds drop off. The resulting equation is linear in terms of h. Okay, I only see single h's to the first power here, so I can isolate those h's on one side and solve for them very quickly. Let's bring the h's to the right. So I've got p squared equals 24h plus 2ph. Of course, at this point we could factor out the h to isolate it. So h times the quantity 24 plus 2p. And that must be p squared. And finally divide by this mess. So I get p squared over 24 plus 2p, and that is my hypotenuse length. And again, since I'm trying to write that length of the hypotenuse as a function of the perimeter, I'm going to write h of p here just to indicate that form. And there we go. We're done. Hope that helps.